So now that we've reviewed how to use logs to solve equations and the relationship between exponentials and log functions, we're going to look at how to graph log functions and what the equation of a log function looks like. So before we do that, let's review how to graph exponential functions. And when we graph parent functions back in Unit 3, we looked at all different types of parent functions, if we recall: quadratics, cubics, square roots, absolute value, and one of the functions that we learned was an exponential function that is in a form y equals b to the x, where b can be any positive base. So let's review that by graphing the equation in A. Y equals 2 to the x power. We know from our parent functions that this is an exponential function. And again, let's make a table. Let's pick our familiar values for x, -2, -1, 0, 1, 2. And let's plug x in to evaluate y. So 2 to the -2 power, right, 2 to the -2 power. Remember, when we have a negative exponent, we bring it down to the bottom. That'll become 1 to the 2 to the second power, which is really 1/4. So 2 to the -2 is 1/4. 2 to the -1 is 1/2. Anything raised to the 0 power is 1. 2 to the first power is 2, and 2 to the second power is 4. So let's go ahead and graph that. -2, 1/4, that's right above the x-axis. -1, 1/2, 0, 1, 1, 2, and 2, 4. And sketch the graph of this exponential function, and we can see that from what we know about exponential functions, we know that there is an invisible horizontal line, which I'm going to highlight with a dotted line orange right now, that my graph of an exponential function always approaches. It gets closer and closer to it, but never quite reaches it. And this line is what we call an asymptote. So in this case, for the exponential function, we have a horizontal asymptote, at the line y equals 0, which is really the x-axis. And let's review domain and range. So if we look at our domain, looks like there's no bound limits on the left. It keeps going to the left and it keeps going to the right. So our domain goes from -infinity to infinity, not including either. And our range, it looks like my graph starts past 0 and it goes up to infinity, right? So my range is gonna go from 0, not including 0, because we know it gets closer and closer to y equals 0 but never quite reaches it, and up to infinity. Okay, so we're familiar with how to graph exponential functions, but now what about the log function? What about something like this? How do we graph that? Well, we don't really know how to graph a log function, but we know how to graph an exponential function. And back in section 1 of Unit 4, well, we learned how to switch from a log to exponential function, right? So if we don't know how to graph a log function, well, let's change it to exponential form, and then we can just graph the exponential function from there. So if I rewrite this log function into exponential form, remember we start with the base and we go around, right? So that would be, if I rewrite it into exponential form, it will be 2 to the y power equals x. And I want you to compare these two equations for a minute. What do you notice? They are very similar, aren't they? Okay, the only difference is that in each case, the x's and y's are swapped. So in the second equation, 2 to the y equals x, the location of the x and y's are swapped. And we had mentioned when we first introduced logs that logs are inverses of exponentials. And so if we want to graph a log function, all we have to do is use the table on the left from our exponential function. and swap the x's and y's, because we know that inverses of each other is where the x's and y's are swapped. And so my -2, -1, 0, 1, 2, which were the x's, are now my y values. Okay, and if you kind of look at the equation, and you have to decide, well, should I pick values for x or should I pick values for y? What would be easier to calculate? You can see that if I pick values for y, it would be easier to solve for x, and that's why we pick values for y. So 2 to the -2 power, that would give me an x value of 1/4. 2 to the -1 power, if I plug -1 in for y, would give me an x value of 1/2. If I put 0 in for y, 2 to the 0 power, that would be 1. 2 to the first power is 2, and 2 to the second power is 4, and you can see that that is the exact same as the y column on the graph on the left. And so log base 2 of x is really just the inverse of 2 to the x power. And so since it's the inverse, all we have to do is swap the x's and y's. So let's go ahead and graph. When x is 1/4, y is -2. When x is 1/2, y is -1. X is 1, y is 0, 2, 1, and 4, 2. And this is what my graph looks like. You can see that as x gets closer and closer to the y-axis, your y values approaches -infinity. So instead of a horizontal invisible line that your graph gets closer and closer to but never quite reach, instead of a horizontal asymptote, because we are swapping the x and y, our asymptote is now going to be vertical. So here is the invisible vertical line that my graph approaches but never quite reach. And so the asymptote, since we're swapping the x and y, the asymptote is now x equals 0, which is the y-axis. And now we have a vertical asymptote. Okay, and because we're swapping our x and y, our domain and range should be swapped as well. And let's see if that matches up. My range looks like no lower bound, no upper bound, right? My range becomes -infinity to infinity, but my domain only goes from 0 to infinity, only on the positive side. So logs are very easy. All it is just inverses of exponentials. So we have the exponential graph and table, and we just swap it. That's all. And so what do we notice about the relationship between the two graphs? Notice that the x and y value of the points are swapped, okay, because they are inverses of each other. So now if we want to graph this graph, looks complicated. Y equals log base 2 of x plus 2 in parentheses, and then plus 1. Let's start by identifying the parent function. The parent function is simply y equals log base 2 of x. This is the parent function. And everything else is transformations. So what do we know about transformations? Everything in the parentheses inside a log is applied to the x. Everything outside those parentheses is applied to the y. And remember, anything applied to the x is counterintuitive. So since it's x plus 2, x is left and right, we know we're going to move our graph 2 spaces to the left. And then outside that will be applied to the y, plus 1, we're going to move the graph up 1, right? And our parent function, y equals log base 2 of x, we got that, that was the same graph that we just made. So we can use the same parent table. And if you want, you could change it to exponential form to help you see it better. 2 to the y equals x. So we're going to pick values for y. -2, -1, 0, 1, 2. And plug y in to solve for x. 2 to the -2, 1/4, 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. Okay, and that's our parent function. And we can graph that. 1/4, -2. 1/2, -1. 1, 0. 2, 1. 4, 2. And that's the same graph that we just made. And I'm going to draw in our asymptote because that's important. That acts as a boundary line. So I know that that's the line that my graph can't cross. And I'm just taking this graph and I'm moving everything left 2 and up 1. Okay, so you can do one of two things. You could take your table, you can do x minus 2, because I'm going left 2. And then y plus 1 and get your new table. Or you could just take your 5 points and just slide it over left 2 up 1, okay? And notice what happens to this invisible vertical line, this asymptote. Since I'm sliding everything left 2, I know that my asymptote is gonna move over as well. So I'm gonna shift that asymptote over. It's now gonna be here since I'm moving everything left 2. Moving things up 1 would not change my asymptote. But left 2, I'm gonna slide everything over, and I know that my graph still can't go past this vertical line at -2. Okay, so I'm just gonna slide everything over. 1/4, -2 is gonna go over left 2 and up 1. And then 1/2, -1 is going to go over left 2 and up 1. 1, 0 is going to go over left 2 and up 1. 2, 1, left 2, up 1. And 4, 2 is going to go left 2, up 1. And here it is. And so here's my new graph. Look very similar to my old one. Everything got slide over left 2 and up 1 space. Okay, and one last example. So graph the following. On the left is the exponential and on the right is the log. And notice that I started a table for you, but we didn't start with -2, -1 because that's generally where the fractions are. But from graphing these a couple of times, you might just know that whenever we graph an exponential function, the negative values are just going to give us fractions, and what happens is it gets closer and closer to my asymptote, right? It gets closer and closer to this invisible line. So we can kind of just draw that in because we know that's what's going to happen, and then we won't have to deal with the fractions too much. All right, so the exponential function y equals 2 to the x plus 5 minus 6. Those are your transformations. Let's start with the parent function, which I know is just y equals 2 to the x. And the 5 is applied to the x, so that's going to move it 5 spaces to the left. And it's going to move it 6 spaces down. Those are my transformations, right? So let's start with the table for the parent function. Y equals 2 to the x. Okay, and so that would be 2 to the 0 power is 1. 2 squared is 4. 2 to the third is 8. And then I'm going to, so optional whether you want to graph the parent and then slide it, or you could just change the values. So I'm going to do, you're going to subtract 5 from the x's because we're moving to the left 5. And then you're going to be subtracting 6 from the y's. So x minus 5, y minus 6. Okay, so my new values are going to be, I'll do it in a different color, 0 minus 5, negative 5, 1 minus 5, negative 4, 2 minus 5, negative 3, 3 minus 5, negative 2, and y minus 6, 1 minus 6, negative 5, 2 minus 6, negative 4, 4 minus 6, negative 2, and 8 minus 6, positive 2. Okay, so then let's graph those. And our horizontal asymptote, let's see where that moved. Since I'm moving, remember we have a horizontal asymptote right here for the parent function, right? And because we're moving it down 6, I know my horizontal asymptote is going to move down 6 as well. Now it's going to be right here. Okay, so now let's graph those points. Negative 5, negative 5. And negative 4, negative 4. Negative 3, negative 2. And negative 2, 2. Okay, and here is my function. And I know that even though I haven't graph points on the left, I know that it's going to get closer and closer to this horizontal asymptote. And that's what my graph is going to look like. And then for the log expression, for the log equation, notice that this is log base 2 of x. Our parent function is this, right? And that is just the inverse of the equation that we just graphed, y equals 2 to the x. It's the inverse of that. And so all we have to do is swap the x's and y's for my parent, because I know that if I change this to exponential form, this is going to be 2 to the y power equals x. And so let's just take my y values from the column on the left and switch it over, and now it's the x, 1, 2, 4, 8. Okay, and then my transformations is x plus 6, so that's 6 to the left and 5 down. Because they're the inverses, the transformation swapped as well. So now I'm going to take my x's and I'm going to subtract 6 and take my y's and I'm going to minus 5. Okay, so 1 minus 6, negative 5, and I'll do that in a different color as well. And 2 minus 6, negative 4, and then you might recognize that, well, these are just the exact same values that I got earlier in the y column, so you can write them down, negative 2, 2, right? And then the y column, y minus 5, is the same as the x column right here. 0 minus 5 is going to be negative 5, so you just have to take your old table, really, and just swap it. Okay, and then instead of having a horizontal asymptote at y equals negative 6, we know that because we're swapping the x and y's, now I'm going to have a vertical asymptote at x equals negative 6. This is the vertical invisible line that my graph is not going to cross over. And so then we can just graph. Negative 5, negative 5. Negative 4, negative 4. Negative 2, negative 3. And 2, negative 2. And so let's go ahead and connect and graph. And again, you know that your graph is going to get closer and closer to the vertical asymptote on the left. And it's going to keep going down, just like that. All right, so go ahead and try the practice problems and show all your work and submit it when you are finished on Schoology.